What if you were dropped onto Earth 4.5 billion years ago? Get ready, because you're about to sprint through a 4 billion year survival marathon. We're stripping away the skyscrapers, the oceans, and the very air you breathe. Rewinding past the dinosaurs and the first tiny cells, straight into the violent birth of our world. It's the ultimate history of us, and it's going to be brutal. We're here. Forget that blue marble you see on postcards. Right now, Earth is a screaming furnace of liquid rock. The sky is a bruised red, and the gravity is crushing. You're standing on a crust that isn't even solid yet, breathing a cocktail of carbon dioxide and sulfuric acid. No water, no trees, no solid ground, just 2,000 degrees of molten spite. See, you're already melting, but don't worry, the real fun hasn't even started yet, because right now, something the size of Mars is screaming toward us at 20,000 miles per hour. Look up, that's Theia. It's Mars-sized, it's going 20,000 miles per hour, and it's about to reset your day. You just got vaporized into a magma ocean 1,000 kilometers deep. But hey, the debris from that crash is forming the moon right now, and the impact tilted the Earth's axis. Congrats, you just invented seasons. Now stop melting and keep moving. 4.4 billion years ago, the planet is finally cooling to a chilly 1,000 degrees. The sky is a bruised toxic orange, no oxygen, just carbon dioxide and sulfur. But wait, it's starting to rain. Not a drizzle, but a million-year acid bath that creates the first oceans. They're hot, sour, and full of minerals. It's the perfect pressure cooker for life, if you can survive the plumbing. Final boss, the late heavy bombardment. For 300 million years, giant asteroids use Earth for target practice, boiling the oceans and turning the ground back into lava. But by 4 billion years ago, the rocks finally stopped falling. The first stable crust is here. You've survived 600 million years of hell. Take a breath. Wait, don't. Still no oxygen? Welcome to the Archean 4 billion years ago. The good news, the planet isn't a liquid light bulb anymore. The ground is finally hardening into basalt and granite. The bad news, it's a constant 100 degrees Celsius. You're standing on a giant steaming radiator. One wrong step, and you're sous vide. Look at the sky. It's not blue, it's a thick, nauseating orange-red. That's methane haze and volcanic dust scattering the light. There is zero oxygen. Just a suffocating cocktail of carbon dioxide and nitrogen. Don't even try to breathe, your lungs aren't ready for this chemistry experiment. The steam is finally condensing into a million-year downpour. This is the birth of the first oceans. They're not crystal clear, they're acidic, boiling, and murky green from all the dissolved iron. You're watching the world drown in its own sweat on the first stable crust. 3.8 billion years ago? Look closer at the shallow pools. See those slimy rock mats? Down in the hydrothermal vents, in a 100-degree mineral soup, the first microbes are waking up. They're thermophiles. They don't just survive the heat, they crave it. Life is officially here. It's tiny, it's smelly, and it's about to pull off the biggest atmosphere heist in history. Ready to meet your ancestors? Archean Marathon starts now. 3.6 billion years ago. Welcome to the Paleoarchean. Earth's liquid iron core has started spinning like a giant dynamo. The planet is finally growing some backbone. More granite is cooling and floating, creating the first real volcanic islands. You're no longer standing on a lava lamp, you're standing on a craton. It's solid, it's stable, and it's surprisingly salty. But don't get too comfortable. In the boiling hot springs and salty depths, meet the neighbors, Archaea. And these guys are the ultimate survivalists. 3.4 billion years ago, something revolutionary is happening in the shallow waves of the Pilbara. Those green-tinged rocks, those are early photosynthetic microbes. They've stopped eating chemicals and started eating sunlight. They're taking CO2 and water to make sugar. It's the first solar-powered kitchen in history. The byproduct of this kitchen, a tiny bit of oxygen. It's not much yet, but it's a slow-motion bomb. Life has found the sun, and the sun is about to change everything. Next stop, the Great Oxygen Heist. 3.2 billion years ago, the Mesoarchean. Cratons are expanding, merging like a giant puzzle. For the first time, Earth has a modern look, at least geologically speaking, but the real action is happening in the water. Look at the seabed. See those red and black stripes? Those are banded iron formations, BIFs. It's the sound of the ocean rusting. Billions of tons of iron are raining down to the floor. It's the biggest industrial waste project in history, and it's creating the iron ore we'll use 3 billion years later. 2.9 billion years ago, Earth hit its first deep freeze, the Pongola Glaciation. Massive ice sheets are carving through the volcanic rock. 2.8 billion years ago, the Archean. The methane haze is finally thinning. As oxygen levels creep up, that nauseating orange sky is starting to clear. And the stage is set. The continents are stable, the iron is buried, and the oxygen is building up like a ticking time bomb. You've survived the long Archean marathon, but get ready. Because the great oxidation event is about to change the rules of life forever. 2.5 billion years ago, the Archean ends in a silent massacre. Cyanobacteria are flooding the world with oxygen, a deadly poison to the old inhabitants. Dissolved iron is oxidizing, raining down in massive red clouds. Methanogens are dying out, their world erased by a gas they never saw coming. This is the peak of the banded iron formations, but once the iron runs out, the oxygen leaks into the sky and it's about to kill the climate. Oxygen just wiped out the methane greenhouse. Welcome to the Huronian glaciation, the longest winter ever. For 200 million years, Earth is a sterile white snowball. Glaciers miles thick are grinding continents to dust. Life is on the brink of total failure, but in the dark, life finds a loophole. Around 2.4 billion years ago, a radical new alliance forms, symbiosis. Though it isn't until 300 million years later that the first physical fossils finally emerge to prove it. The first complex cells, eukaryotes, are quietly emerging from the ice. Life didn't just survive the freeze, it upgraded. Ready for the next leap? 2.3 billion years ago, the Rodinia, the stream of lava. The ice is finally retreating, but Earth isn't just warming up, it's boiling over. Massive volcanic eruptions are tearing through the crust, fueling the birth of a new giant, the Supercontinent Columbia. With the ice gone and oxygen stable, life isn't just surviving, it's diversifying. Look closely at the tide pools. The first red and green algae are appearing. They aren't just simple cells anymore, they are the pioneers of complex multicellular structures. 2.0 billion years ago, the Ordovician, the mountain range period. Earth is building its first great mountain ranges, but the violence isn't just coming from below. A massive asteroid, the Vredefort impact, strikes the planet, a scar 300 kilometers wide that still exists today. Between volcanic fire, mountain building, and cosmic hits, the stage is set for the modern world. Earth is no longer a baby, it's a powerhouse. Yet there is a catch. As the Earth trembles, the atmosphere betrays its inhabitants. The oxygen levels that fueled the first eukaryotes begin to crash. The grand experiments of early life are swept away, and the planet is about to fall into a deep, billion-year silence. 1.8 billion years ago, the Stetherian, the chaos of Earth's youth is fading, the supercontinent Columbia has fully assembled, a massive firm anchor for the drifting crust. For the first time, Earth feels structurally complete. Deep in the crust of Oklo, something impossible is happening. Concentrated uranium, mixed with groundwater, triggers a natural chain reaction. These are the world's only natural nuclear reactors, pulsing with energy for hundreds of thousands of years. Earth is a planetary powerhouse, but as the land stabilizes, the ocean turns into a trap. We enter the age of the Canfield Ocean. Oxygen vanishes from the deep, replaced by a toxic, stagnant brew of hydrogen sulfide. The seas turn a ghostly, deadly purple. This is the dawn of the boring billion. Yet in these poisoned waters, acritarchs emerge. They are growing larger, armor-plating their cells with complex walls to survive the toxic tides. They aren't just cells anymore. They are the first whispers of multicellularity. In this era of quiet strength and purple shadows, the blueprint for all complex life was being drawn. 1.6 billion years ago, the Cambrian, while the surface seems calm, the supercontinent Rodinia is expanding, stretching its rocky skin across the globe. The planet is settling into a long rhythmic peace. Deep below, the inner core begins to solidify. This iron heart powers the geodynamo, strengthening Earth's magnetic field. An invisible shield now deflects the solar winds, guarding the atmosphere. The cradle for complex life is finally secure. In the sunlit shallows of the Octasian, life makes its most radical move. Red and green algae are no longer just growing, they are evolving. 1.2 billion years ago, Bangiomorpha appears, the first organism to master sexual reproduction. No longer just clones, life began to mix, match, and accelerate. They call it the boring billion, but look closer. Mitochondria are now the engines of every cell. Complexity is exploding in slow motion. The stage is no longer just set, the actors are learning their lines. Ready to meet the first true masters of the ocean? 1.2 billion years ago, the Hadean, the supercontinent Rodinia is complete, fused by massive belts of metamorphic rock. Earth is now a single silent giant island, but the stillness is a lie. Heat is building deep beneath the crust. 1.0 billion years ago, the Devonian, the age of stretch, the giant breaks. Massive rifts tear through Rodinia, carving new shorelines. Molten rock bleeds as new ocean basins expand. The world is being reshaped, 1 mile at a time. In these new seas, the boring billion ends. Acritarchs peak in diversity, evolving spines and armor. Rising oxygen fuels a faster metabolism. Life isn't just surviving, it's competing for the future. The continents drift, the lands divide, but as oxygen rises, the atmosphere destabilizes. Earth is preparing for its most brutal test. The oceans are about to turn white. Ready for the deep freeze? 720 million years ago, the Cryogenian, Rodinia's breakup shattered the climate. Earth is now a snowball. Glaciers miles thick meet at the equator, sealing the oceans under ice. It is the most extreme crisis in history, nearly silencing the pulse of life. But life clings to volcanic hot springs and tiny pockets of water. This isolation forces a radical shift. Cells aren't just surviving, they are specializing. In the darkness, the ancestors of all animals are forged by fire and ice. 635 million years ago, welcome to the Ediacaran. As Gondwana assembles, a new world emerges. No shells, no bones, just soft, strange giants like Dickinsonia. Our first true animals, including sponges, are finally visible to the naked eye. Complexity is no longer a dream, it's a reality. These soft-bodied pioneers are reclaiming the oceans, laying the groundwork for the greatest biological explosion the world has ever seen. Are you ready for the Cambrian? 541 million years ago, the Phanerozoic, the age of visible life. The long silence of the Proterozoic is shattered. No more hiding in the shadows. Life has found a new weapon, the hard shell. For the first time, the Earth's story is written in stone and bone. Welcome to the Cambrian. In a geological blink, every major body plan emerges. From the legendary trilobites to the first chordates like Pacaya, our own distant ancestors. Nature is experimenting with everything at once. From here, there is no turning back. The journey to the land is about to begin. 485 million years ago, the Ordovician, a world of vast shallow seas. Diversity explodes, giant nautiloids with straight shells rule the waters, while early jawless fish dart through vibrant coral reefs. Life is thriving in a golden age of sapphire oceans. But Gondwana drifts south, dragging the world into a deep freeze. Sea levels plummet, oxygen vanishes. In a heartbeat, 85% of all species disappear. 444 million years ago, the Silurian. The ice melts and a new world is born. In the damp margins, a miracle happens. Cooksonia, the first vascular plants, rise from the mud. Life has finally claimed the shore. Behind them, the first arthropods crawl into the sun. 419 million years ago, the Devonian. Plants invent lignin, the wood that lets them touch the sky. The first forests rise, their roots anchoring the earth, while beneath the canopy, fish like Tiktaalik begin to do the unthinkable. They walk. But growth comes with a cost. Expanding forests flush nutrients into the sea, choking the oceans. Anoxia triggers another mass extinction. 359 million years ago, the Carboniferous. Oxygen levels skyrocket to 35%. In this hypercharged air, insects grow to nightmarish sizes. This is a world of endless swampy coal forests. As Pangea assembles, life finds a new breakthrough, the amniotic egg. Creatures like Hylonomus can now lay eggs in the soil, finally breaking the tide of the water. but the rainforests are about to collapse and the era of giants is drawing to a close. 299 million years ago, the Permian. Pangaea is now a single, colossal desert. The lush swamps of the past are gone, replaced by endless red sands. Here, the synapsids rule, like Dimetrodon with its massive sail catching the harsh sun. 252 million years ago, the Great Dying. In Siberia, the Earth splits open. Massive volcanic eruptions poison the air and acidify the oceans. 90% of all species vanish. It is the closest life has ever come to total extinction. The pulse of the world nearly stops. The Triassic. Amidst the recovery, a new lineage emerges, the first dinosaurs like Herrerasaurus and our tiny shrew-like ancestors, the Mammalia forms. Life is small but fast. 201 million years ago, the Jurassic. From the wooded mountains of the Jura, Pangaea is tearing apart, creating warm, shallow seas. In this humid paradise, life reaches for the sky. Massive sauropods like Brachiosaurus become living mountains, roaming forests that stretch to the very poles, but the shadows hold danger. Allosaurus, the lion of the Jurassic, patrols the ferns, and in the canopy, a miracle, Archaeopteryx. Half dinosaur, half bird, it takes the first clumsy flaps toward New Kingdom, the air. 145 million years ago, the Cretaceous, the age of chalk. The earth begins to bloom as the first flowers appear, inviting an explosion of insects. On land, the giants reach their peak. Tyrannosaurus rex and Triceratops rule a world of shifting continents and drifting empires. 66 million years ago, a flash brighter than 1,000 suns. An asteroid strikes the Yucatan, joined by the fire of the Deccan Traps. In an instant, the reign of the dinosaurs ends. 75% of life is gone. The era of giants is over. The stage is cleared for the small, the fur-covered, for us. 66 million years ago, the Cenozoic knew life. As the dust of the asteroid settles, the small and the fur-covered inherit the Earth. Continents drift to their modern homes. India slams into Asia, pushing the Himalayas into the clouds. Antarctica freezes over, sending a chill across the globe. Forests retreat, giving way to a new vast frontier, the grasslands. 23 million years ago, the Neogene. The Isthmus of Panama bridges the Americas, sparking a great migration. In the African savannas, the grass grows tall. 4 million years ago, Australopithecus stands upright. The first footprints of our lineage are pressed into the dust. 2.58 million years ago, the Quaternary. Great glaciers carve the valleys, while Homo sapiens emerge into the cold. 11,700 years ago, the ice retreats, leaving a stable cradle for civilization. The Holocene has begun. The story of the Earth ends, and ours begins. 46 million centuries, countless extinctions, and one miraculous survival. This is our story, a story written in stone, ice, and DNA. If you enjoyed this journey, don't forget to like, follow, and share. Let's keep exploring the wonders of our pale blue dot together. See you in the next era.